Hi everyone, I'm Paweł. Uh, on a daily basis, can you hear me well? All right, awesome. So I work as a software developer, as a consultant in a software house called Visuality in Warsaw. And I'm extremely interested in topics around domain-driven design, around event sourcing, event-driven architecture, and so on and so forth. Event storming as well, so everything event-related. But enough about me. Today, I'm going to tell you about event sourcing and what can you do with it in Ruby. We are going to talk about what it is. Then I'll go over basic concepts that you cannot really go without when talking about event sourcing. And then I'll give you a short introduction into a toolkit that you can use in Ruby. So let's start. Meet Mary. She's a client of our e-commerce, and she's been with us for years. She's made only one purchase, and we also know that she's into chess, and she's also interested in crime novels. Let's see how we know that. Of course, our e-commerce uses a very classic relational database. So we have a users table. Inside, we have an entry for Mary, her name, Mary Jane, her last name, Parker, and her email, mary.watson. Well, it doesn't really match, but whatever. And we also have the creation date, so we know when she has created her account. Let's go forward. I've said that she's only made one purchase. So we have, of course, orders table, and some order items, well, as traditional, as classic as it gets. As for her interests, we have yet another table that joins interests and users. So we know that she has expressed interest in two subjects. To sum it up, we have data stored in a relational database. That database, that information stored in database is persistent, and it's our source of truth. There were some events while she was using our application, she's made some changes. But those changes were transient. We didn't really care about them, we just cared about the final state, which is saved in our database. So we know who, well, Mary, what she has done, well, in what state she has left our system. Let's meet Mary one more time, but now through every change that she has introduced to our system. So once again, she's a client and has been with us for years. So at some point, she has made a change. She has made a change in our system. She has created an account. She has created it with the first name Mary, last name Watson. Well, now the email matches, right? It's mary.watson.domain.com. Then she has set her last name and first name over the years. So she's made an update. Later on, she's done one purchase. So she has added something to her order, then another thing, then she's adjusted the quantity. Well, she's added too much at first. We all know that already. But if we go further, we see that she has added one more thing. Then she was thinking about it for, if you look at the time, for a day or so. Then she removed it and finalized the order. As for her interests, we already know that there are two, right? So she's added two interests. But then she removed those and replaced with something else. If we sum it up, we still know that she's our customer. And she's been with us for years, but we also know that she has adjusted her first name and her last name. It's possible that she has been married or divorced. We know that she's made only one purchase, but now we also know that she was interested in a survival kit. On top of that, we know she's into chess and crime novels, but she used to be into hiking and sailing. Now, the data is stored as events. And those events are persistent, and they are our source of truth. We can sum up all the events and figure out what's the current state, but that state is transient. we can always remove, well, forget about the final state and rethink the events one more time to figure out what it is. So we can now analyze the entire history. We know who, again, Mary, in what state is right now, but we also know why. Because if we can analyze all the steps, we can come up with a history, what has really happened. And that's called event sourcing. Event sourcing is a pattern for storing data as events in an append-only log. So we store events and we append them at the end of our log. We never modify events from the past, just like in real life. We all would like to do that, but we can't. We can only add new events at the end of our log. And it's very important from the event sourcing point of view that those events are stored in the order that they really happened. Let's see where it could be useful to have all the events from the past. Let's imagine that you have an application where your team members create documents. They have to create it, they have to say they are done, and someone has to approve it. So this would be a normal path, right? Someone has created the document, said, I'm done, and then someone approved it. But this is an alternative. They could have finished their document, then someone from the team could have rejected that. They would have to fix the document or change, then finalize, and then approve. Maybe in your team, there is someone who always gets rejected. Or maybe there is someone who always rejects others. If you only have a field in your documents table, in your relational database, let's say, and you can only see that it's approved, you don't see the entire history. Let's take a look at a very classical example of a shopping cart. We have two shopping carts. One on the left has 2 items. Someone has finalized the order afterwards. And on the right, someone has added two things, then added the third one, removed them, the third item, and finalized the order. Let's think for a second if they are the same or different. Quite the same, right? We've sold just as much stuff on the left and on the right. However, the information that comes with it, the information that comes from the left cart and from the right cart or order in general is much different. Maybe the guy who was ordering the order on the right, maybe his paycheck was late. Maybe his wife was looking over his shoulder. And maybe that watch was a bit too expensive. Maybe we should advertise it to him in a day or two. The marketing value is quite obvious. But in general, the information about the client is priceless. A third one for, let's say, for the DDD enthusiasts, cargo location. Let's ship some cargo overseas. Let's imagine we have this big boat that goes overseas to Miami or whatever, and we want to track its location. So we always want to see where it's at. So again, we have this dialog that says current location. So we have a first, oh, sorry, not this way. So we have a first measurement, and we update the current location field. Again, obvious. Again, there was some miscommunication. There is no signal. We don't have a new measurement, but the last one seems quite all right. This happened again, but fortunately, in a few moments, we have a new location, so we just update our current location, and we live with it. We reach the final destination. And when it happens once, we really shouldn't care, maybe. But if we don't have all the events, if we don't store all the measurement events, then we miss something. Maybe we miss that on that path, all our ships go through Bermuda Triangle. So the thing is, don't lose data if you don't have to. if you have a point in your application that people can, or a system can reach using 2 different paths, and you don't know which path was taken, you've just lost data. You kind of cannot put a price on that. You might have a vague idea how much it might be worth, but how about in a year, or 2, or 3? You cannot put a future price on the data that you've lost, because more often than not, you even didn't know you should have stored it. All right, so that's event sourcing. It's a pattern for storing data in an append-only log, and that's pretty much it. But if you want to talk about event sourcing, the learning curve is quite steep because you have to understand a few concepts to start really talking about it. We'll go over these concepts, so, well, you'll know them already. But we'll be talking about those concepts in a context, because there are many technologies, many ways to start with event sourcing. Even in Ruby, there is more than one. So in some of those technologies, the concepts are named a bit different, or they mean something a bit different. So I'm going to tell you this in a context in a Ruby toolkit called event-type projects. It's a toolkit for creating event-sourced autonomous services, at least by the book. However, you can use it for any type of project. It comes with an event store, because we have to store our events. It's called MessageDB, and it comes with a very nice test framework. It's called Test Bench, and you can use it for any Ruby project, including Rails. All you have to do to start with it, you have to forget anything that you've ever learned about RSpec, and you're good to go. So event sourcing, we have to have an event concept. You can describe an event in different ways, in real life, let's say. But in here, it's a message. If you have a component that has done something, it publishes an event, publishes a message to broadcast that it has done something, there was a change. So an event is a message with a specific purpose. What could have happened? Someone could have deposited money into a bank account, or someone could have added a line item, or user might have been registered. So those are names of events. So if something happened, it had to have a cause. That cause could be a command. Command is also a message saying you do something, so it's a request. So command is a request to do something, and event is an effect of of processing, for example, processing a command. But both are messages. And I've said that I'm going to show it in the context of event-type code toolkit. So this is how we would define those messages in code. Those are very simple Ruby classes with just a bit of syntax, so you can define attributes of such a message. All right. So we have command and event, both are messages. Let's take an entity, order entity, and let's give it ID 7. What can we request from that entity? We can say add line item, as we've said, or add shipping address, right? So if we take every command that we've requested from that entity, they are organized in something called a command stream. Streams are fundamental unit of message organizations, but you don't create streams. You just create a message and say, okay, your message are in this or that stream. In this context, where's this button? This is how a command stream for an order 7 would look like. That's the name. And if we want to see the commands for this, again, commands for this entity, we would look into this command stream. And once we process those commands, well, there might or might not be events that were produced. Similarly to the command stream, this would be an event stream. This is like the most important stream, in fact, because this stream contains all the events that has happened. So every change that has happened. So in fact, this stream contains all the information about this entity. All right, so we have commands, we have events, we have messages. We have to store them. So we have a handy thing called MessageDB for storing messages. It's, the beauty of it is that it's implemented on top of Postgres. So all you have to do, all you have to have and know to start with event sourcing in Ruby is Postgres. You can install MessageDB over it, and well, it's a single table implementation, so it's not complicated. Of course, there is a lot of other database stuff inside. I won't get into that. But there is only one table, and it contains all the messages. Let's quickly go over what's inside so you have a general idea. Global position is a sequence. So it's a sequence number of a message. We start from 0 and go to gazillion. Position is, again, a sequence, but within a single stream. Time, when it happened. Stream name, well, we've gone over that. Type, that would be class of a message. So for example, add line item or line item edit. Data, well, that's kind of important. This JSON containing all the attributes and their values, all the attributes of a message. Metadata, another JSON, but this one contains information how the message came to be. So, for example, why or was correlated to some other stream, for example. An ID, of course, we need a message ID. We have to identify each message. But in this world, we use UUIDs for those. All right. I've said that we have commands, something processes them, and we have events. What's that something? It's called a consumer. So consumer is a process. Let's give you a reference. It's like if you started a Sidekick unit, a Sidekick process, for example. It just runs and it processes. It reads, and consumer reads, constantly reads messages from a single category. It produces them, applies business logic based on those messages, and produces events. Let's go inside. So inside of consumers, we have something called handlers. Handlers are business logic blocks. So each handler is responsible for handling a specific type of message. So for example, we would have one handler for deposit messages, another, for example, for withdraw. What can you do from a bank account? Or like close account, for example. So one handler for one type of a message. And if we want to look at the code, it looks like this. Just a bit of DSL, of course. But we have something like handle block. I cannot really see the screen, but it's somewhere here. And such a handler block handles a specified type of message. And at the very end, for example, it can publish a message like here, deposited. I'll show you a bit more of that later on. So going back to our consumer, we know it reads, we know it processes, and we know it writes. And this is where stuff gets interesting. A consumer doesn't have to read commands. It can also be triggered by events. Probably you can imagine that you can model any type of logic like this. So you have a message, something reacts to it. For example, finalize an order. That's a command, right? Something processes it and publishes an event called order finalized. So once an order is ready, what can we do? Maybe some component will start to generate invoices. Other component would start thinking about notifying some other services. Maybe we have some packing of our shipment to do, or whatever. So any consumer can publish events or can issue commands. It reads, processes, and writes. And such a creation, as you see on this, let's say, diagram, is called PubSub. PubSub is a messaging pattern. In here, we have publishers that publish messages, but they don't really care to whom. They publish messages into a specific category. And that's it. Publisher publishes message to a category. In here, streams. We also have subscribers that subscribe to those categories and read messages from them. But publishers do not think about subscribers, nor subscribers think about publishers. They are independent from each other. They just communicate over a category of messages. All right, this one's for me. All right, so we have just two things to go over. All right, so how the handler, after receiving add line item command, how would it know whether it can add this command or add this line item or not? Let's say our order has an invariant saying, hey, you can only have 2 line items. How would it know whether it can add another one or not? Line items could have been added and removed in the past. So it has to go through all the events from the very beginning till the very end and see how many line items we have. If it's 0 or 1, we can add another line item. As you can see on the screen, if we go over every event, we can figure out a current state. And that's called projection. So if we take the event stream and go over all the events and sum up all the information that we have there and create a static state out of this, this is called projection. Why we do that? For example, as I've mentioned, to make a decision. So a handler would do that to make a decision. However, by far, it's not the only not the only reason we do that. We can also, let's imagine you have like 1,000 orders, and you want to find an order that has a total value of total amount of more than something. You wouldn't query the streams, right? They are really not for that. What you query is normally a relational database because it's meant to serve you in this purpose. So you can take all your orders, project everyone, and put in a relational database, let's say. Therefore, you create something called a read model. So it's a model of data that you just read from. For example, you can present it on your website as a list of orders or a single order. And the very important thing is that if you have this final static state of your entity, you can put it into any data model. It doesn't have to be a relational database. It can be a graph database because maybe it's much easier to process your data, your relations in a graph, as a graph, or document database, or whatever database that suits you. All right, so that's projection. Let's take a very quick look how this relational database projection will look like. On the left, we have an account. Again, a bank account. We can deposit, we can withdraw money. On the right, we have a relational database and a table called accounts. Someone has deposited. On the left, we have an event, deposit amount of 3. And on the right, we create a data model of account that has an ID and a balance, not amount, but balance in that model. Someone has deposited more, so the balance has increased. If we withdraw something, of course, it lowers. But something has happened. Another event was published. Withdrawal was rejected because someone asked for too much. That doesn't update our relational database. The projected state is the same. And if another deposit comes for another account, well, we have a second row. All right. And this is the last thing I wanted to say about. Let's combine our consumers, PubSub, and projections. So we have let's stick with this order idea. So we have orders and events. Let's have a consumer that reacts on every event related to an order. It continuously reads all the events, processes them, and creates projection in a relational database. Sorry. So we have our source of truth in events, but it's constantly projected into a relational database where we can read from, for example, for our UI. In this way, we've just separated writes from reads. We write to our system using commands, but we read from a relational database. And this split of reading and writing gives you an enormous freedom that you start to appreciate once you use it. Of course, the data in the relational database is not consistent, not all the time consistent with what you have in events. It's called eventual consistency. The data in a relational database is eventually consistent, but you can deal with that, and that's not always a drawback. All right, so we've talked about what event sourcing is and the core concepts. Let me show you how it works. I've kept you in the realm of event-type project, so the examples will be from there as well. You can find available projects, example project that event-type team uses in their workshop, but you can download them. They are not really that well documented or not documented at all because they are for kind of their internal usage, but you can go over all the commits. They are very well maintained from the first time to the last one and learn a lot. How you do that? You just clone a repo, of course, and, well, bundle up. Then what we need is the mentioned MessageDB. And fortunately, it's just a gem. Let's assume that you have your Postgres already installed. You install the gem, and with the gem, you get a whole set of CLI commands. One would be create DB. And here, you already have your MessageDB installed with some default values. So we have a ready component. What can we do? We can go into this and launch something called an interactive test. You might imagine that when you build autonomous services, they don't really have UI. Those consumers, they are not meant to have any UI at all, in fact. So if you want to change something in your system, you have to do it from CLI. Those interactive tests are meant to give you that freedom to say, OK, deposit some money, for example, or write command to like this one, write me a command for deposit. I've adjusted a bit what's inside of this file just to give you a broad idea, but without going into some of the details. But it does more or less this. It defines what account ID we want to use. Well, we initiate an object. This is a command object. We put data in it. We define what's the stream. It's should be pretty readable. And in fact, we could just write it by, well, we could have just given a string in here because we know what it should be. It should be account command 1 to 3. And we write stuff in our database. Well, I've said that it's no UI really, but fortunately we have a viewer. This is the viewer. So we can launch a viewer and open it in a web browser. It will show you all the streams, commands and event streams you can browse, and you have all the events within. Right now we just have one event, one command stream. And there is the command that we've written. Deposit command, when we click on this rectangle, we get all the details of that message. All right. So we've written a message and nothing happened. Awesome. Let's start up a consumer that would consume that message and hopefully produce an event. It's already part of this component that we've cloned, so we just have to start it up. As a result, we get another stream, now an event stream. Deposit command, deposit event. Let's do something more fun. Let's write a bunch of commands. So we deposit, and we draw 3 times. Each time we deposit, we put into amount of 11. Each time we withdraw, we get the amount of 10. So this is the result. We've already seen that with our projection example. At the very end, the last command to withdraw was rejected because there was not enough money. Since we are looking into Ruby code, let's see how it looks there. So we have a stream of events called account. So we have an account entity. So it's an account class, as simple as that. It has some module included, just for the sake of being able to define the attributes of this class, of this entity. But it's as simple as it gets. The entire event project is extremely object-oriented, well, in a good way. So we have properties and we have behavior. The next thing that we have defined is a class that would describe how an event changes this entity. When we start projection, we start from the very first event. But it works like this. We take an empty account entity, and we apply all the events one by one. So we have to know how to apply those events. It's not like in the handler that had some logic for each type of message. No, we already have those events. We just have to apply information to project it in some way into an entity. And this is a class, again, just a bit of DSL. So we have apply blocks. So apply this kind of event this way. The last thing that we need, and don't read too much into it, it's an idea of a store. It's just a mechanism to bind this entity with this projection. Because, in fact, you can project an entity in different ways using the same events. But that's maybe for another story. OK, so we want to project. So we take our store. We just configure it with this build. And we say which entity, so which ID we want to get. And we say store, hey, fetch. And this is what we get. So of course, if someone wanted to withdraw 11, well, it was just a bit too much. All right, so let's go quickly over one more example. This one is a bit more complicated, and I'll kind of just swoop over it just to show you what's the complexity of such an example. And if you'd like to maybe see it in action, or talk a bit more about it, let me know afterwards. So now we are going to make fund transfer. We have two accounts. We have money on the first account, and we want to transfer it to the second account. So what do we have? What do we need to do? We have a fund transfer component, just as we have an account component. But first, we have to pre-deposit some money to the first account. Right. So this is nothing new. We have an account. We issue a command called deposit. It has deposited. Awesome. Then we issue a command to our fund transfer saying, hey, transfer me some money. I didn't put the command in here for the sake of clarity, but we initiate this transfer, and the first event that comes out of it is not funds transferred. It's not as this simple of an image, but our process is initiated. So the first event in the fund transfer stream is called initiated. While creating this event, we issue a command to the account stream, to the account, saying, withdraw some money. Once it's withdrawn, our fund transfer component is subscribed to this stream, this category, so it realizes, pops up, as you might remember, it realizes, okay, something has been withdrawn, I can react to that. So once it has been withdrawn, we write our own internal withdrawal event. Those are completely different, just the name is the same, because the meaning is the same. So we write withdraw event, and once we know that money has been withdrawn, we can issue a deposit command to the second account. Once it's deposited, we are subscribed to this event as well, so we write our own deposited event. When we know money has been withdrawn, then deposited, our job is done, and we register that by publishing transferred event. So this means our job is done. In fact, there is a bit of gimmicks related to idempotence, which I didn't really want to go into this tonight. But if you understand all of this, including the idempotence stuff, unfortunately, but if you understand all this, you are ready to start your production level event sourcing. There is quite a lot of things within, but if you spend some time and understand all of this, you're good to go. Awesome. So you know what event sourcing is. You know the core concepts. You know at least one library to start with it. But right? It has been all Ruby. Awesome language, awesome technology, but to connect it into Rails, it's not that easy. Let's just show you like 2 examples, and that's it. I won't bore you with more. So first one I already shown. This is a command. If you create your own component, or take the account component, and put it in your gem file, because it's a gem, you can write this. And you have your commands. So your Rails application can issue commands. They then start to live in the event source world, but you've just connected the worlds. And you can apply all your new knowledge in your new component. And another example, maybe not of event sourcing, but to apply event-driven architecture. So no projections, but you can react on events. You all know this. You have a service. it does this and that, you know. And when it finishes, you want to schedule the next step. So you use a scheduler. So you take, for example, Sidekick. You say, OK, at the end of my service, run next thing in a while, asynchronously. But you can flip the control flow and do this. So you have your service, and at the very end of your service, you publish an event. Then you have your consumer, I've talked about, which reacts on that event and performs that asynchronous operation using PubSub. And just like that, your service doesn't have to know what's the next step. You've just decoupled this from this, and you don't have to have one subscriber, you can have more. So we've just achieved an event-driven architecture in our Rails application. I want to leave you with just a few resources. So first of all, well, I've used Eventide, so a link to them. And Eventide Slack, they are extremely helpful. So just write something and you'll get an answer for sure. And 2 presentations. In fact, if you were to take anything from this presentation, you have it in those 2 links. Like, forget about what I've said. Go watch this. You can actually, well, not everyone agrees with everything Scott says, but he's a beautiful mind, and he really tells a lot of things that can actually change the way you think about different stuff, about how to use Ruby, how to write microservices, how to use how to write autonomous service in general. Please go watch it. It's like 40 minutes, and we cannot have a discussion about events without mentioning Greg Young, sorry, Greg Young. Go watch this. This is the presentation that got me started. And if you want to learn a lot about event sourcing, just go on the internet and find everything Greg Young has ever done. Watch it, and you'll learn a ton. So please go there and just have a watch. Thank you. That's all. Do you have any questions?
Thank you very much. That was very interesting.
Thank you.
On one of the slides, somewhere in the middle, where you showed us how to write projections, if I remember correctly, there was something about assigning a sequence. Could you please explain what's the meaning of it?
Let's just make sure that we are on the same page.
Sure.
Is it here, or
no? That was a code sample.
Code. Oh, okay, I get it.
I hope it's not too detailed.
Yeah, I was really thinking to get rid of this line, because it's actually a real life code from this component. Okay, so it's actually a sequence. So it's number of an event within this stream. So you just have the idea in which, let's say, version this account is in here. So it's actually just a number. So it's just a sequence of the event in the event stream. So it's not more than a version of this projection you're in, because actually you don't have to project into the final state. You can check how the event looked a year ago or 2 years ago. And you can check how would your code react, for example, on the next event or the next command. So again, just a sequence to give you the idea where you're at.
Thanks.
I also have a question about projection. I assume that this is reasonable to, if I have an event and then there is, for example, we have some projection based on order streams. and a user did something that affects all of these projections. So for example, user had 10 orders, so there is 10 different projections for these separate orders, doing something, whatever. And user did something that affects all of these all of these 10 order projections. How would that be executed? Like in parallel, like one by one?
Projection is a creation in a realm of single stream. Like if we have two streams, they have nothing in common. Like you can model your system to, let's say, join two events, two streams to produce something. But again, that's non-trivial, but doable. But I don't know if that answers the question.
So there is basically a rule: one projection is based always on one stream, and that's it.
I try to imagine how would we. I think at this point, yeah, I'm really having worse time wrapping my head around your question. But I think it's well, yeah, you project a stream. That's like that's what you do. Yeah, that's pretty much it.
So you mentioned that we never lose data, but sometimes we need to lose data. For example, to comply with GDPR or other regulations. What then?
It depends, as always. But let's say you have your user stream, and you might have another stream, like user profile or user GDPR protected data. Let's say that user wants to be forgotten. You can remove that stream without really affecting your stream, as long as you model it like this. So if you keep all the GDPR related data in one stream, and this is like a side stream, like a user profile, you can still have the idea that user was there. So you have the user ID and it relates all the things that they've done. You can drop their personal information. If you want to do more, there are a few tricks, but you have to think about it before you start. You have to design your system in a way. If you have some, let's say, encrypted data, you can lose your encryption key. So it is still there, but you have no access to it. So you cannot identify personal information of that user. It's not that you cannot lose data. You don't lose data if you think about every piece of data. You can still delete it, but carefully. But you think about every piece of data and you don't lose it unintentionally. Like with this, for example, cart idea, when someone was adding and removing stuff. I've worked with like 50 plus e-commerce sites, and we were always analyzing abandoned carts. Someone who has added some things into cart but never finalized their order. But we really never, maybe it was our fault, but we were never thinking about things that people have removed from their carts before they finalized an order. So we basically just kept losing data. So it's just thinking about the data. You can drop it if you really, really want to.
So one more thing about you said that you can't allow the data to be lost in the system, and I think that in reality we actually do the opposite. So we basically consciously decide like what to store and what to lose in the system, because like some of the data, okay, in the e-commerce solution that you've showed is like, okay, it's pretty obvious. You can probably make some, like generate some new some revenue from the data that's been stored. Mm-hmm. But in most of cases, I think it's like the data would be maybe useful for debugging, but it won't generate you any like an additional revenue, or it would be just a cost, an additional cost to store it, and maybe it would be even illegal to store it, right? So I think it like most of cases, it's quite the opposite way.
I would dare to ask, how do you know that?
How
do you know if, let's say, the amount of interest your latest collection were, well, let's say you have one collection and you are thinking next year, hey, should I create a collection that's similar? Let's see how much movement it has created.
Are you talking about like in case of the e-commerce solution that you've shown? It might be like I guess it's like lots of data user generates might be useful for like.
I know you can always go into that world, that realm using your marketing tools, so Google Analytics or segment.
So another thing is like storing like typing patterns or like I don't know mouse movements or whatever. You have a level that you just say stop. It's not worth to store anymore. Maybe
two things. First of all, the e-commerce. Oh, three things. Sorry. First of all, e-commerce can be done using event storage, event sourcing, and there are very smart people in this room that will tell you so. Second thing is that now that I've worked with event sourcing, I agree that I consciously think about what data is lost and what data is stored. But if you don't start thinking about it at some point, you lose data. You actually lose data. And third thing was, two things should be enough, but let's talk afterwards. I know. Even this order idea, it's so useful as a learning technique, as an example that everyone understands. But events, I personally prefer events in those services that are autonomous. So you model your logic using events. You don't have to model your entire application using events. And that's, again, a conscious decision. But this order idea is just very nice to present those ideas on. How useful is it in real life? Again, it might be done like this, and there are examples of that. But how useful that is, let's talk afterwards.
Thank you very much. It was quite helpful. And you showed one example with Postgres. And you showed the way how would we store an event, some base attributes, key attributes, right? Let's assume that we build probably some payment domain, event-based project or architecture. We design architecture, and we have lots of events, and we build it from scratch. And probably we would have some events versioning, right? Because potentially our events could be updated in the future. Some new attributes will appear there. And what do you think? Would be better to use NoSQL database, for example, MongoDB or AWS DynamoDB, than Postgres? What cons and pros do you see? Could you share?
If you could keep the mic for a second, because I have to ask you something. What would you like to use this NoSQL DB for, in fact? Like, what's the purpose of that database for you?
Yeah, the purpose that as a result, we should store our events, right? Or we should store some entities that will be a result of projection, as you showed us. And since the events, they could be updated, new attributes could appear. For example, we had some events version 1 and version 2 has been implemented and designed. Probably then we should have more flexibility, right? And maybe in some cases we should also update or edit our tables. And maybe here we would be more flexible if we use NoSQL databases. We would need to use, we wouldn't need to use some migrations, right?
Sorry, let me stop you. Sorry, because we are getting very specific. You're talking about events versioning, and that's like a broad topic. And I still don't know where you're getting at with this NoSQL database, I would love to answer, but let's put it like this: 2 beers and we can talk. Okay.
Cool.
Awesome.
Yeah, I'll accept it.
I have just one more question about these
Awesome.
projections.
Mm-hmm.
Because you told that at some point we can make the projection to create this read data model, so we can read from it. And is there any policy around how often should it be done, or every event, every message should end with some projection, or can we just do it on our own? Is it that much connected to how fresh data we need on the?
Yeah, exactly. You've just answered, I think. Let's say you've issued a command, it gets processed, an event is published, something reacts on that event and creates a projection. Let's say it takes like a second, more or less. It doesn't have to take that long, but let's say. So all you have to do is go to your client and ask, well, okay, is 3 seconds okay? And if you ask what kind, like, should we react on every event? Again, it's a business question. Should we have, how fresh this data should be? Because in fact, what people don't really realize that they never see fresh data. If you open like an index page with orders, or well, order is a bit different, but let's say product list or a product page, it's already expired. Because if something has happened half a second later, you don't see it. So you just move time by 3 seconds, let's say, and you just have to realize to the business, because they usually answer, no, it has to be an immediate thing. You have to learn them that it doesn't, because most often than not, it doesn't. And well, let's say, okay, so you start from that second, so non-instant, and you build on top of that, but usually you can just do it more or less instant.
And one technical question arises from this. So how do we know that the projection is the most fresh or not? Is it like the sequence, where the sequence come in? So we just compare the sequences, number of all messages and so on? Because I believe that at some point of our project, it would be pretty hard to build every projection from the scratch, or to compare our projection, our read model, with all the events that happened from the beginning of the project.
First of all, you have to learn to build short streams. By short, I'm saying tens of events, not thousands of events. So the projection is not that long. Second of all, so we have read models and you have that event streams. So you never perform business decisions, I mean the application business level decisions based on read models. So read model is something for reading. Someone can make a human decision based on a read model. But so how fresh? Well, it should be up to date, because why not? There is really no technical obstacle to make it up to date. But the business decisions, they are always based on an up-to-date decision, because this projection for a business decision will be always done the moment that this business decision is processed. It's not always started from the very beginning. They are snapshots of your streams, so you don't always have to start from the very beginning. So it's quite fast, but I've just lost track. So I think I answered more or less.
Yeah, I believe this snapshot is the when it comes. So, so is it the part also on the event-type project, or is it somehow built in? Yeah?
Yes.
Okay.
So you can adjust as you like. I think it's like 100 events per default. So a snapshot would be made, but I can be wrong.
Okay. Thanks very much.
Thanks.